Hello, welcome to the channel. I'm Igor, and eSun sent me some filaments for the testing, and in this video I will test their PLA filaments reinforced with glass fibers and carbon fibers. They also sent me some ABS filaments too, and these are the HT and glass fiber versions, but they will be tested in a separate video. Now let's talk about these fibers added to filaments. Earlier I already saw that they are added to materials which are hard for printing. Nylon, polycarbonate, sometimes even ABS, because these fibers will reduce the warping and the object will be more printable. Now, adding them to PLA filaments, we don't have this advantage anymore because even the regular PLA is quite printable. And in most cases, the layer adhesion will be weaker because this fiber will reduce the cross-section area. These are not real fibers because otherwise they will clog the nozzle, almost like powders. But sometimes if the load is in direction against those orientation of the fibers, they may help. I will do the detailed testing with these filaments, but three cases where the fibers always helps. One of them is the temperature resistance. The second is actually they will hide those layer lines and we will have really nice printing. And the third one is if you want to anneal the PLA, they will reduce the shrinking, deformation and the warping. If you are not familiar with annealing of the PLA, you can raise the heat deflection temperature from 55 degrees Celsius to almost 150 degrees Celsius. I have several videos about it, but of course we will have some deformation of that object, so it's not so easy. Outside of the box I don't see too many information, so only one I have these stickers, so I will take them out. The carbon fiber version is in black color and the glass fiber is in some kind of white. And in both cases the print temperatures are between 190 and 230 degrees Celsius, bed temperature between 45 and 60 degrees Celsius, and the fan maximum. Don't forget these are abrasive filaments and you need some kind of hardened steel nozzle for it. Now according to the eSun, the 0.4 mm size should be enough. So far my favorite eSun PLA filament is their PLA+. It's great filament and I already tested it several times on this channel, but usually on some bed slinger. And recently I started a poll on my YouTube channel and because I wanted to move to some correct SWI printers, and most of you voted to the Bambu X1 Carbon. So from now on my test objects will be printed on this printer. I'm starting the printing with glass fiber filament. And I noticed the end of the filament is locked with the stick tape. When I tried to remove it, actually it broke off. And from now on this is very risky material because there is a danger that it will tangle or jam. So I unrolled here 10 meters of the filament. Look how brittle is this material. And I hope everything will be okay. This is X1 carbon. And I'm setting here generic PLA-CF material. And I also check in the Bambu Studio. The properties, default settings, the maximum flow rate is 12 cubic millimeters per second. The Bambu version of this material is actually 15 by default. Here you can see some real-time footages of the printing, if you are not familiar with the speed of this printer. I will include here only one time lapse because the light color is better on this camera. These are the last two objects for the layer adhesion test. And with some bending it is very easy to remove the objects. And then moving to the carbon fiber version, here the end of the filament is in the holes and immediately I check it is brittle material but less brittle compared to the glass fiber filament. And I will use here the same G-code like with the previous printing. Again some real-time footages you can see here, and really beautiful surfaces we get thanks to these carbon fibers. Objects are prepared, ready for mechanical testing. I already have several tests in the progress, so these are some PLA materials and some TPU filaments. Let's start with the mechanical test. So these test objects are printed in horizontal position. I'm starting with the glass fiber filaments. The average 74.5 kilograms, the break load, and now the carbon fiber version. 80.8 kilograms is the break load. And they broke more or less very similarly on the smallest cross-section area. And then the layer adhesion test. These test objects are printed in vertical position, and this is quite low break load on the glass fiber filament. Now let's see the carbon fiber version. 34, this is really acceptable, especially that this is reinforced with carbon fibers. And now two-sided shear stress. In both cases those fibers really helps in this case. Over 170 kilograms is the break load. Break correctly in 3 pieces. And now 3-point bending test. Here you can see my equipment where all loads are placed on it, but I will place them one by one. And I will measure the deformation after 130 and 60 seconds. It was interesting to see more initial deformation on glass fiber filament, but later on higher loads, more deformation on carbon fiber material and some creeping too. And after this I can hardly see any deformations on these objects. And now the torque or twist test. I'm starting with the glass fiber filament. I'm measuring the load at a 90-degree angle and the maximal load, and this snap very quickly on 1.3 Nm load. This is the carbon fiber version, and it is less brittle compared to the glass fiber, so I almost made a full rotation. And here you can see the deformation didn't break in two pieces. And now the eyes of the impact test with these notch test objects. Well, let's see which material is more brittle. Glass fiber, 0 position. Carbon fiber. The carbon fiber is in two pieces, but the glass fiber is still connected on that one layer. And now let's analyze the picture. So this is the 0 position of the hammer, and this is after breaking the glass fiber material, and this is after carbon fiber object. And if I measure everything from the 0 position, I can calculate the breaking energy. These are very brittle materials, and in both cases very similar toughness. And the temperature test, and these two objects are the subjects from this video. This is a time-lapse speed-up video. It was hard to spot the exact moment, but first significant deformation I could notice at approximately 65 degrees Celsius. I'll stop the experiment now because I'm curious how soft they are. Interesting to see that because of those fibers they don't deform too much, but they are quite soft, and actually this is softer than this one. These are some regular PLA filaments, and actually they are harder now than these materials here. The deformation on these two objects is very similar. The creep test, the deformation under the constant load in next 5 days, and the load will be 1.25 kilograms. Locking the position for more accurate measuring the distance between two reference surfaces, and similar values I have in both cases. Day 5, and I think smaller deformation is on the glass fiber version. 1479, 1609. And now let's remove the load. Side by side, minimal, but more deformation on carbon fiber version. Let's analyze the results in this Excel table, which you can download from mytechfun.com website. And let's analyze the creep test, and I can see that the glass fiber had less deformation, but here the creeping is more important. So the difference between 2 days we can see on this table or on this graph, and even in this case we can see that the glass fiber filament creep less compared to the carbon fiber version. On the tensile test, the difference was not so big, but the carbon fiber was a little bit stronger. Now on the layer adhesion test, the carbon fiber is very good, but the glass fiber is quite weak. Anything below 20 kilograms is not acceptable from my side. On the shear test, the orientation of these fibers really helps if this is printed in horizontal position, so it was very strong in this kind of test. And now the bending test. Now this is the deformation under these given loads after 30 seconds, but more interesting is this graph. And here we can see on smaller loads less deformation on the carbon fiber version, because here actually the base material resists to this stress. And look at this, on 10 kilograms, when actually it starts with the bending and the fibers take over the stress, here the glass fiber is better compared to the carbon fiber version, and also the carbon fiber version creeps here a little bit more. On the torque or twist test, the load at 90-degree angle is more important, and it was equal in this case, but yes, glass fiber was very brittle. After half rotation it snapped in two pieces. On the eyes of the impact test, very similar values, but in both cases these are very brittle materials actually. And on a temperature test, it started to deform at approximately 65 degrees Celsius. It was hard to notice the exact moment of the deformation. It could be a little bit higher, but yes, they are better compared to the regular PLA. It was interesting to see that two fiber reinforced materials act differently. The best example here is that bending test. On a smaller loads, the carbon fiber version was better because here the base material take over the load. And when the deformation became bigger, then partly the fibers take over that load, and here the glass fiber version was better. I believe that partly this is because of different material types, of course, but also I noticed under the microscope that the glass fibers are a little bit bigger in diameter compared to the carbon fiber version. Now, somehow I cannot really like the filament if it has a weak layer adhesion. Of course, there are always applications where we don't need big layer adhesion, and actually if the orientation of those fibers will resist to the load, in that case the glass fiber filaments are even better. About that annealing I mentioned at the beginning of the video, I have two more carbon fiber PLA filaments on the testing, and after this I will choose one and do that annealing test with that filament to see if it is survive it and not deform too much, because after this I may get high temperature resistant objects up to 150 degrees Celsius probably. And if you want to get notification about that video, you should subscribe and click that bell button, otherwise there is a big chance that you will not get the notifications. And how would I know this? Well, it is very simple. If I have almost 47,000 subscribers and my average views per video is between 2 and 4,000, and half of those actually are not subscribed, then it is not suggested. Approximately, I know how this works. Unfortunately, it looks like that YouTube decides in advance how much views will the video get, and it is suggested until you don't reach that number. For example, my Hungarian channel has 2,000 subscribers, and last 10 videos get average 1,200 views. What a coincidence, but the topic is completely different, and I cannot believe that exactly this number was interested into this video. Okay, so I don't want to complicate things. The point is that the video will be created, and if you want to get the notifications, you should definitely click that bell button too. Thank you for watching and happy printing!